asymptote. Same thing over here, towards the asymptote and towards the horizontal asymptote like that. And that's the graph for number 23. Alright, so for 26, it's already factored for you, so there's nothing to factor. So the domain would be all x such that x cannot equal 0 or 3, because those are the values that would make the denominator 0. It has no holes because nothing canceled in the numerator or and denominator, no common factors. X-intercepts, it has none because the numerator has no zeros. No x's. So then, therefore, it has no zeros. The y-intercept, we cover up the x's, and we end up with. Oh, I'm sorry, we can't even use this. We can't. I just realized x cannot be 0, right? It's undefined, so it has no y-intercept. Okay. So the vertical asymptotes are y equals 0 and y equals 3. This one's a bottom-heavy problem or function. The numerator is degree 0, the denominator is a cubic, third degree. So this one would be y equals 0, horizontal. Alright, so I just realized I had written for the vertical asymptotes, I had written y equals, and it's actually x equals, so I fixed it already. So those are the equations for the vertical asymptote. So those are the ones that are going to go first on the graph. So x equals 0, so right over the y-axis, and x equals 3. And then the horizontal asymptote at y equals 0. Okay? And no intercepts, right? No x, no y intercepts. So the only thing we can do here is, this one's going to have a few more, we're going to have to find a few more points. So we have to pick a point on this side because we're going to have one curve on this side, one curve right here, and one curve right here. Okay? So I'm going to pick, and there's no symmetry here, right? So we can't say, oh, if it's, we've got to find points in each region. So I'm going to pick negative 1. So f of negative 1, and I'll write here on the left side. So f of negative 1. So that's going to give you 2 over negative 1 squared times negative 1 minus 3. So I know it's kind of messy. So that's going to be 2 over negative 1 squared is 1, and negative 1 minus 2 is negative 4, so it's going to be negative 4. So negative a half. So negative 1, it gives me negative a half, so the point's going to be right here. Okay, so with that, I know that the curve is going to go towards the asymptote and towards the asymptote like that. Okay, then I'll pick 1, f of 1. So that's going to give you 2 over 1 squared times 1 minus 3. And so that's going to give you 2 over negative 2. 1 squared is 1, 1 minus 3 is negative 2, so 2 over negative 2 is negative 1. So f of 1 gives you negative 1. Now I'm going to do f of 2 also because sometimes the graph, remember the graphs could cross the horizontal asymptote, they could. So I want to know if it's going to cross it here or if it's going to go down. Okay, so I'm going to pick f of 2. And actually, let's see. Because of any number less than 3 is going to be a negative. So, well, let me just get the value so I can get the point, and then I'll connect the points. So it's going to be 2 over 2 squared is 4. 2 minus 3 is negative 1. So that's negative 4, so it's negative a half. Like that. Okay. So it's going to go something like this. At some point it's going to turn back down because it's not going to go up ever, not in the middle section, because the numbers are always going to be in negative numbers. Oops, sorry about that. So it's going to go down like this. And then on the right side, I'm going to pick another number, 4, let's say. So f of 4. And if the point is down here, well, it won't get in the way. So f of 4 is 2 over 4 squared times 4 minus 3. So that gives you 2 over 16, so it's 1/8. Okay, so 4 and 1/8. So it's really close to the x-axis. Okay, so then it's going to go close to the asymptote. Oops. And it approaches the x-axis. So this is what the graph looks like. And again, check with Desmos.com. I didn't do it beforehand, but I can check. We can check after. All right. So for number 29, we're going to factor first. Okay. So we're going to factor the numerator. You get x plus 3, and then in the denominator, factors that add up to positive 1 that multiply to negative 6 would be x plus 3 and x minus 2. So this tells me the domain is all x such that x cannot equal negative 3 or positive 2. We have, let's see, right here, well, let me use this color. This is a common factor, right? So this one's going to cancel out. So that's going to create a hole in the graph. And the hole is when x is negative 3. Replace, so we're left with x over x minus 2, correct? So now I'm going to replace the x with negative 3. So that gives me negative 3, let's do the work right here, negative 3 over negative 3 minus 2. So that gives me negative 3 over negative 5. So it's 3/5. Okay, negative 3, positive 3/5. X-intercepts, you look at what makes the numerator 0. Now the numerator that is in the reduced polynomial, in the reduced function, right? In this one, not in the original. So now that would be 0. And remember, if the x-intercept is 0, 0, the y-intercept has to be 0, 0. There's no way around it. Cover up the x's and that's what you get, right? 0 over negative 2. Vertical asymptote, there's 1. X equals positive 2. And because this is another powers equal, the numerator and denominator have the same power, we look at the coefficients, the leading coefficients, y equals 1 over 1, which is 1. Okay? Alright, so I'm going to go ahead and draw the asymptotes first. There's x equals 2, y equals 1, and after that we draw, change of color. We draw the intercepts, so there's only one intercept, 0, 0 right here. And then there's a hole, this time negative 3, 3/5. So negative 3, 3/5 would be about here. Okay, I'm making it like really big. Because the marker or the pen I can't get any thinner than that. But that's where the hole would go. Okay, so now we connect. This goes towards the asymptote, through 0, 0, and then to the asymptote. On the right side, it's probably going to be, oh no, it has to be, right? It has to be, not probably. It has to be on this part over here. Because if I draw a curve down here, then it forcibly has to go through the x-axis. And it can't, because the only x-intercept is 0, 0. So the graph is never going to cross the x-axis on this side at all. So it has to go up here. So just to get an accurate point, so it's not way off, I'll just plug in, let's see, 3. So f of 3, oops, f of 3 is 3 over 3 minus 2. That's 3 over 1, that's 3. So 3, 3. 3, 3, 1, 2, 3 right here. And again, towards the asymptotes, the vertical and the horizontal. And there's your graph. Alright, for 33 through 41, they ask you to graph the functions on a graphing calculator. So go ahead and you can use desmos.com if you don't have a handheld one. And then they ask you to identify the domain, the vertical asymptote or horizontal horizontal asymptote, whatever, if it has one. So on 33, the domain would be all x such that x cannot equal 1, because 1 would make the denominator 0. Since nothing cancels, there's no common factor numerator denominator, so that means that there's no whole, so that 1 becomes the vertical asymptote. And this is a powers equal function. The numerator denominator have the same power, and it's leading coefficients are 1 minus over negative 1, so that's negative 1. For 35, the domain is all x such that x cannot equal 0, because 0 makes the denominator 0. Again, there are no holes here, so then that means that 0 becomes a vertical asymptote, because it's not a hole. This is another powers equal rational function, so we look at the leading coefficient, so it's 3 over negative 1, so it's negative 3. For 37, the domain is all reals. No restrictions on the domain. Nothing makes the denominator 0. Vertical asymptote then would be none. Okay, and horizontal asymptote, since this is a bottom-heavy rational function, the horizontal asymptote is 0. Y equals 0. So 39, we go ahead and factor. We get x minus 3 times quantity of x plus 2, and the domain would be all x such that x cannot equal 3 or negative 2. Now notice that there's no common factor, right, in the numerator and denominator, so nothing cancels, so that means that the vertical asymptotes will be x equals 3 and x equals negative 2. This is a bottom-heavy function, because the degree here is 1 and the degree here is 2. It's a bottom-heavy, so it's going to have a horizontal asymptote of y equals 0. Alright, we can subtract these two rational expressions right here to create 1. And so the common denominator is x times x squared plus 1. So I get 20x, I guess I could do x squared minus 1 times x squared plus 1 all over x times x squared plus 1. Okay, so I got a common denominator. This is now squared because I had to multiply this one by x over x, because I needed that to have a common denominator for both fractions. And then this one gets multiplied by x squared plus 1, because again, that's what I was needing in this denominator here. Okay, so now, we look at the denominator, and we see that x cannot be 0, because even though right here nothing makes this 0, but I have this factor, right? So x cannot be 0. Nothing cancels in the numerator, there's no common factor, so vertical asymptote is x equals 0. This is a bottom heavy, right, because the numerator has a square, is the power, the 2, and the denominator is cube, because right here this is going to be x cubed. And over here, after I distribute and combine like terms, I'm still going to have an x squared. So this is a bottom heavy, so it's y equals 0. Alright, so the domain for this, for 49, is all x such that x cannot equal 0. And It has no holes because there are no common factors in the numerator denominator, right? So it has no holes.